So students, let's move on to our last question of composite functions. Over here, our topic composite functions is going to end, and in our next lecture we will be starting with a new concept of derivatives. So let's begin with the last question. We have log of x plus root of x square plus a square minus x plus root of x square plus a square. That's a very important question. We are going to derive the derivative over here of this particular problem. I want you to memorize that problem very thoroughly, the question itself and its answer directly. There is no need to remember the entire solution, because sometimes in CET and in JEE exams it has been observed that the question directly comes, the application of the problem directly comes in the exam. So make sure that you remember the answer for this particular question like a formula. So let's begin with the problem. We have y is equal to, I'm going to write it, y is equal to log of this particular function. Now it can be written as log of a upon b, isn't it? We can see that it is log of a upon b. So I can write log of a upon b as log a minus log b. But again, I'm telling you that whenever a question comes, have a watchful eye about the question, make some observations with the problem. That will really help you out to write a better solution. So if you take a very close look about the question, you see that the terms in the numerator and denominator are almost same. There is only a change of sign. I can write this as log of root of x square plus a square plus x and root of x square plus a square minus x. Did you see? I have simply changed the order of the terms. The way the terms were written, I have simply reversed it. A plus b can be written as b plus a, and the denominator was minus a and plus b, so that is written as b minus a. So it's very simple over here. Now if you take a look at the denominator and the numerator, they are more or less same. I'm going to rationalize the denominator. Let's rationalize the denominator. Now when I say rationalize the denominator, it simply means you have to multiply the denominator by its exact conjugate. You want to multiply the denominator by its conjugate. The denominator here is root of x square plus a square minus x. Its conjugate is very simple. It is going to be root of x square plus a square plus x, isn't it? Now this term also needs to be adjusted in the numerator. So the numerator also gets root of x square plus a square and x. So I have rationalized the denominator. Let's close the bracket. Now the denominator certainly looks like a minus b into a plus b, and a minus b into a plus b becomes a square minus b square. We all know that's basic mathematics. So a minus b into a plus b, that's going to be a square minus b square. What's a here? It is root of x square plus a square, square of that term. So square of this term, if I do, the root sign will vanish from there. Then the other term is b, square of it is going to be b square. So my term is going to be log of the denominator. I'm going to work first. That's a minus b into a plus b, gave me a square. That means square of this root vanishes. You get x square plus a square minus of b square, which is simply x square. You can very well say that x square gets cancelled. In the numerator, if you observe, it is simply a plus b and a plus b. So a plus b when multiplied with a plus b gives me a plus b the whole square. So I'm going to write root of x square plus a square plus x the whole square, and you close the bracket. Now if you take a look, the log term looks like there is some numerator and there is some denominator. So that looks like log of a upon b. I hope you all know the basic formulas of logarithms also very thoroughly. Log of a upon b gives us log a minus log b. So I'm going to get log of a upon b as what? Log a minus log b. So let's write that next step. I'm going to get log of a, which is log of root of x square plus a square plus x the whole square. Let's keep it in a bracket. That was log of a minus log of b, so that's log of a square. Now log of a raised to m, isn't it? See, extensive use of the rules of logarithms is done over here. So you got to know your basic knowledge of mathematics very thoroughly. The basic rules of logarithms. If you observe, this is log of a raised to m, and log of a raised to m is m log a. So that 2 comes down, log of root of x square plus a square and plus x minus 2 log of a, 2 log of a. So that's a simplified form of a very big question. See, it's a very simplified form, isn't it? Now we are going to proceed further to get the derivative of this function. So now I'm going to write differentiate both sides with respect to x. So let's get the derivative of the given function. Okay, so I'm going to differentiate both sides with respect to x. So I get dy by dx is equal to d by dx of whatever is present in the previous step. The entire thing is going to come. Now, if you write this entire thing over here, did you observe the first term is a function of x? The first term is a function of x, but the second term is a constant term, isn't it? The second term is a constant term and its derivative is going to be 0. So now I can definitely say I have to just work on my first term. The second term was a constant term, that's why its derivative came 0. So let's take the derivative of the first term itself. Over here also I can see the 2, which is a constant, so 2 goes out, and derivative of log of something in x, isn't it? Something of x. Your knowledge of composite function is going to get tested over here. You see log of, there is something of x present inside over here. So that's like log u. Derivative of log u is going to be 1 upon u, and again derivative of u. So I write 1 upon u, which is root of x square plus a square plus x into the derivative of u. That means I write d by dx of root of x square plus a square plus x. So let's keep this thing in a bracket. So I get the answer as 2 upon, so let's reverse the term and write it x plus root of x square plus a square. Not needed, but for simplicity purpose I have written x first and then root of x square plus a square. Even if you don't write it, it's not going to cost us anything. Let's move ahead. Let's get the derivative of the terms present inside the bracket. If you see derivative of first term and second term, I want to take. The first term is root. The first function you see is root, and inside the root something of x is written. So it will be treated as root u, and derivative of root u is 1 upon 2 root of u, which is x square plus a square, isn't it? Root of x square plus a square, root, and then that x square plus a square is taken as u. So root u, derivative became 1 upon 2 root u, and again derivative of the u, which is x square plus a square, and plus because there is a plus sign here and one term is still left, isn't it? Derivative of x, it is going to be 1, and you close the bracket here. So there is only one term left now to be differentiated. Let's quickly get the derivative. Now remember, there is a very big bracket over here, a very big bracket, and then 2 belongs to the bracket itself. So this 2 and 2 cannot be cancelled. You have to be very careful with the cancellation of the terms. The 2 outside the bracket and 2 inside the bracket, even they are very close to each other, will not be cancelled because this bracket is a very big term. So 2 and 2 cannot be cancelled. So you should always keep an eye on such kind of confusing terms. Okay, so that's my first term. Then I put a bracket, there is 1 by 2. Then there is 1 upon root of x square plus a square. So I write that term also. And now I see derivative. I want to take derivative of the two terms. The first term is x square. Derivative of x square is 2x, and derivative of a square is a constant term, so its derivative is going to be 0. So derivative of a square becomes 0. Derivative of x square is going to be 2x, so I write 2x over here, and then the plus 1. Let's not forget the plus 1, very important term. So what happens here? Here the 2 and 2 cancels, this 2 and 2 cancels, isn't it? The 2 that has been cancelled, you need to take a look which 2 has been cancelled. Now things left inside the bracket can be cross multiplied, so I get my answer as 2 upon x plus root of x square plus a square. Do the cross multiplication, you get x plus root of x square plus a square. upon root of x square plus a square. So have you observed there are two terms, one present in the numerator and the other one in the denominator, which can be entirely cancelled, and the final answer that you are going to get is 2 upon root of x square plus a square. So did you observe initially when I started with the question, it was a very complex question. At first moment, at the first sight, one might think that the problem needs log a upon b formula, which is log a minus log b. But if you are very watchful, if you have a very close eye, if you do good observation, you can see that the terms in the numerator and denominator are same. So I'm going to do rationalization, and the rationalization has reduced my problem to a very considerable amount. So the problem got reduced and I used my concepts of composite functions, and I've got my answer finally as 2 upon root of x square plus a square. So students, this is all that you have to know about composite functions. I guess these many problems are enough to understand conceptually how to tackle composite functions. Now, what your job is, what your part is, that you have to take a look at all these questions very thoroughly, very properly. Make sure that you keep writing the notes, you keep preparing your notes very properly, and then do not forget to practice as much as you can. Practice will make you an expert of this topic. There might be a chance that there might be some questions that you might not find very comfortable with. Please do not hesitate to ask in the comment box down below. Put up an image of the question that you have found it difficult to answer. I will make sure that I come back with the solution to you. So students, this is where I'm going to leave you with the concept of composite functions. You have a very great day ahead. We will meet in our next lecture with a new concept. Thank you so much for watching.